Hello, today we will look at Unit 2, Day 4, Domain. Our objective today we will determine the domain of functions. I will write the domain as an inequality. Your assignment will be a worksheet that does have a front and a back. Unit 2, Day 4, Domain. Remember, a relation is made up of inputs and outputs. The domain of a relation is the set of all inputs that are used as part of the relation. In most problems, the domain is thought of as the x values. Let's determine the domain for each relation below. We're going to start with mappings. Remember, on your mappings, on the left-hand side, those are your inputs. And on the right-hand side, those are your outputs. Domain are your inputs. So 0, 1, 3, 5, and 6 are my domain. When we have a set of numbers, we write them as a set. So I start with a curly bracket, and then I list my numbers from smallest to greatest. So 0, 1, 3, 5, and 6. And then I close my set with another curly bracket. The next example on this mapping, take 60 seconds and try this one yourself. Let's see how we did. We have our inputs on the left and our outputs on the right. We are worried about the inputs today. So we have from 0, 3, 5, 6, and 7. That is the domain for this mapping. Remember, we don't just have mappings for relations, we always also have other such things, such as tables and graphs and ordered pairs. Let's look at tables. Remember, our domain are our input values or our x values. We do this the same way as we do the mapping. We start with a curly bracket and then list our values from smallest to largest. -7, -4, -2, 8, 10, and 19. We close our bracket at the end. That represents the domain for this first table. Take 60 seconds and find the domain for the second table. Let's see how we did. I'm looking at my x values. I start with a curly bracket and write -19, -6, 1, 2, 15, and 18. And I close with another curly bracket. That is the domain for the second table. Let's look at, now we've seen some mappings, some tables, let's look at ordered pairs. So here I have a set of ordered pairs, and let's find the domain for this set. Remember, your domain are your x values, your input values, the first in each pair. We also want to make sure we write our order, our points, or our numbers from smallest to largest. So when I start with my bracket and I look at my numbers, -9, 5, there's 2 zeros and an 8. My smallest number is -9. We're going to write them smallest to biggest. So I'm going to start with that -9. My next smallest number is 0. My next smallest number is 5. And the last number is 8. Then I close with another curly bracket. Notice there were 2 zeros in this domain. I only have to write them once. There were 2 zeros, but I only had to write them once. Here's another set. Let's take 60 seconds and see if you can write the domain on your own. All right, let's see how we did. You should have started with a curly bracket and then started with our smallest value, -3, followed by 0, 2, and then 3. Again, there were 2 number 2s, but we only had to write 1. So now we've looked at mappings, we've looked at tables, we've looked at ordered pairs. Let's look at graphs after we review our objective again. Today we will determine the domain of functions. I will write the domain as an inequality. So far we've been writing our domain as a set of numbers. We still need to write it as an inequality. That's going to come into play when we look at the domain of graphs. Remember, there are several different types of graphs. The first one we're going to look at is discrete. So when I look at discrete, they have individual points as opposed to connected points. So that means I'm going to have individual x values or individual input values. Again, we want to go from small to large, so on our graph we're going to start at the left. We're looking for the x values and small to large. So I start with my open bracket, and then my smallest x value will be my point that's furthest to the left. Then we look up and see where it's pointing to on the x-axis. My smallest x value is -3. I go across my graph, and the next one I see is -2. I keep going across my graph, and the next one I see is at +1. There's another one at +1. I don't have to write the 1 again. And then I have one on the x-axis. I also have +4. Those are all of my points. Those are the x values for all of the points. I end up closing my bracket, and that is the domain for this discrete graph. Let's look at another one. 60 seconds, see if you can find the domain for this discrete graph. let's see how you did. You should have looked at your graph and noted the x values for each point. So my first x value was -3, followed by -2, 1, 2, and then 5. Now we have a continuous graph, meaning my points are connected. On this one, it does say 2 endpoints, but this one actually doesn't have necessarily like one length to it, since it's a shape and not just a design of a graph. But we're still going to follow the same method each time. We're going to look for the farthest left point. So when I look at that graph and I look at the farthest to the left, the smallest x value I can have, I see the farthest left point is right here at -3. Then I'm going to look for the farthest right point. That is going to be over here at +3. The next thing I'm going to notice is that x can be anything in between. If I trace my fingers along the sides of this shape, I can see that I'm going to get x values at anything between -3 and +3. Here is how we are going to write our value. We're going to find our smallest number, the one furthest to the left. Then we're going to use an inequality and say less than, or sometimes equals to. Then we're going to use our variable. Since we're domain, those are the inputs, that's going to be x. Then we're going to do another inequality symbol that will always be less than. Sometimes we will also use equal to. And then you'll find your biggest or your farthest right value. So that's going to be how we're always going to start setting up our inequalities from a graph that's continuous. So my smallest number on my graph is going to be the one furthest to the left, which is -3. You're always going to use a less than symbol. Then you need to look at the point and you need to see, is it closed or is it open? Since this one is, the graph actually closes there, there's not an open circle on the original graph, we are going to say we can equal that point. Then you're always going to use an x. Then you're always going to use a less than, sometimes an equals. So you're going to look farthest to the right and see on that point, is it solid? Is it closed? If it is, then you get to equal the farthest point to the right. And we look at what that number is and we write that on the end. That number for us is 3. This is what your final answer for the domain looks like. This is saying that -3 is less than or equal to x, which is less than or equal to 3. And basically what that means is your x values have to be somewhere between or equal to -3 to 3. Let's look at another example. All right, so here I have another function graphed. I'm going to start by looking what is the point that is farthest to the left. So I'm going to start on the left side of my graph and I'm going to go over till I hit the first point I come to. And I'm going to note where that point is. Then I'm going to do the same thing from the right. I'm going to go until I touch the graph the very first time and I'm going to note where that point is. Then I'm going to compare those 2 points and see what their x values are and highlight the x-axis between them. So notice I just drop those points down and I note the x-axis between them. I'm going to use that piece on the x-axis to write my domain. Remember, we're going to start with the smallest on the left, which is -1. Then we're always going to use a less than symbol. If I have a solid dot, I'm also going to be equals. Since I do have a solid dot right here, it's not open in there, that little square is not open, I'm going to have my equal bar. Then I'm always going to use the letter x, less than on the right, and then we're going to look at the right hand side. If it's solid, if it's filled in like this is, then we're also going to add an equal bar. What is that farthest to the right value? It is 1. So this is saying x is going to be between or equal to -1 and 1. Next example. Here, I do have an open end and a closed end, so we need to make sure we're being careful with that. I'm going to follow the same process. I'm going to start on the left side of my graph, and I'm going to go until I hit my graph, which happens before I even move right here. I do take note that it's an open circle. Then I'm going to go over to the left-hand side, and I'm going to go, the right-hand side, and I'm going to move to the left until I hit the graph. Right here. I note that that is a closed circle right here. Then I'm going to take those 2 points and I'm going to move them to the x-axis, keeping in mind that this one needs to be open and this one needs to be closed. X can be anything in between those 2 points. Now I look at my smallest number all the way over to the left and see it's -5. We always use a less than symbol. Because this end is open, I'm not going to put a bar underneath the symbol. I'm going to go straight on to putting an X. Then I'm going to put another less than symbol and look at the other end. This end is filled in, so I do want an equal bar. And what is that biggest number? That biggest number is 4. So this is saying X can be in between -5 and 4. And it can equal the 4, but it can't equal the -5. That is the domain for this graph. Next example. Let's look at the objective one more time. Today we will determine the domain of functions. I will write the domain as an inequality. And now we've practiced doing that. But we're going to do a few more examples to see some different ways you might see it. So here we have continuous and I have one endpoint. I'm going to start on the left and travel right till I hit my graph to find my smallest point. I'm going to take note that it's an open circle. Then I'm going to start on the right and I'm going to move to the left till I hit the graph. And I'm going to take note that there's an arrow on that end. Notice I drew an arrow, or a triangle, indicating it's an arrow. Then, just like before, I'm going to take those and drop those down to the x-axis. There goes my circle, and there goes my arrow. And I'm going to keep it as an arrow. I'm going to note that I can be anything in between those. But the arrow indicates I can keep going as well. That's what the arrow says, I can keep going. So when I look at my smallest value, I see it's right here at -4, and it's an open circle, which means I cannot equal it. I have to be less than. I'm still going to use an X. Now when I look at my big end and I have an arrow, that means I can be any number bigger. I can keep going and going and going, so I don't have to fill out the rest of this inequality. This is my finished inequality. However, when we first did inequalities, we did talk about the fact that we don't want to keep our x's on the right. We always want to have our variable on the left. So remember, when you switch your number and your variable, you also have to invert the sign. This is my final answer. X has to be greater than -4. So all of these x values, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, anything bigger than -4, 8, 9, 10, 11, 12, anything will work in this function. Because that arrow is going to keep going, it's going to keep moving to the right. Let's look at another one. All right, same process, start on the left. As soon as you hit the graph, put what that endpoint is. In this case, it's an arrow. Then I'm going to start on the right and I'm going to move till I hit the graph and note the endpoint. In this case, it is a closed circle. I'm going to move those two ends to the x-axis and highlight in between them. Then I'm going to notice on my small end, I have an arrow. That means I can go forever that direction. So I don't need the inequality. I can skip straight to the x. On the other end, I'm still going to use a less than, and I have a closed circle, so I also get an equal to and 4. So then I need to remember that the variable has to be on the left, and it is, so I'm done. This is saying that x can be any value that's smaller than or equal to 4. So any value going this direction will work for this function. Let's look at another example. All right, so same process, start on the left, go till you hit the graph, take note of that end, it's an arrow. Start on the right, move till you hit the graph, take note of that end, it's also an arrow. Move those ends to the x-axis and highlight in between them. Notice I have arrows on both ends. If I have arrows on both ends, that means I don't have any inequalities. I can go forever to the smallest number you can possibly think of, and I can go forever to the biggest number you can possibly think of. That means there are no numbers that won't be part of this domain. The way we write that is we say it goes forever in both directions, so we say all real numbers are in this domain. The domain is all real numbers. You'll learn when you get to Algebra 2 that there are some numbers out there that are imaginary and not real. We won't work with those this year, but we will still refer to them as all real numbers. Let's look at another example. All right, same thing, start on the left, note the endpoint, go to the right, note the endpoint, take them to the graph. Keep the same endpoints and highlight in between them. Again, I have arrows on both ends, meaning I can go forever in either direction. So all the numbers work, all real numbers. Let's look at the next example. All right, again, start on the left, go until you hit the graph. Now, if there's not a point there when you hit the graph, if it doesn't have an open circle, that means it does touch that point and you get a solid dot. Then start on the right, and when you hit the graph, take note of the ends. The next thing we do is we take both ends and we take them to the graph. When I look at this, I can see even though it had two arrows, those arrows were in the same end, right? And so they go the same direction. I need to also keep the idea of this is the end of the x's, okay? Maybe not the end of the graph, but the end of the x's as far as how small they go. So my smallest value is going to be 0. Can I equal that 0? Yes, because there was not an open circle there. So I get to have an equal bar. Then I have an arrow, so I'm going to put my x, and I'm going to remember that since I have an arrow, I don't have to put the bigger end. It goes forever and ever and ever, so that is my inequality. 0 is less than or equal to x. However, we don't want to have our variable on the right, we want our variable on the left. So I'm going to switch my x and my 0, and when I do that, do you remember what happens to your inequality? It has to be inverted. And so my final answer for the domain of this graph is x has to be greater than or equal to 0. All of these x's that are bigger than 0 or equal to it will work as part of the domain, part of the x values for this graph. Let's review our objective one more time before we start our assignment. Today we will determine the domain of functions. I will write the domain as an inequality. Okay, now that you've watched the notes, let's work on our assignment. You're going to complete the front and the back, and you want to make sure that you have it ready to go to turn in on Monday. If you finish it today in class, you are more than welcome to turn it in today. Thank you so much for watching.